So let's move on to the mesos. We kept calling them boreal intraseasonal oscillations or mesos, monsoon intraseasonal oscillations. The two terminologies do imply some kind of a thought process behind them, because when you say monsoon intraseasonal oscillations, maybe you think of Indian Ocean processes, even though you have the 10 to 20 day oscillations that are propagating northwestward, and there are tilted structures extending from the southeast to the northwest, from the western North Tropical Pacific to the northwest of India. But when you look at something like this is a nice animation of precipitation over a certain period. And if you focus on the time when sun crosses north, and you can see here into May, the marine ITCZ stays on the ocean, the monsoon trough gets set up, and the strong southwesterly winds create upwelling and cold temperatures along the East African coast, and you can see that the rainfall almost disappears here. And all the action is on this side, on the western, on the eastern side. So if the ITCZ is remaining there and you are trying to form another tropical convergence zone over there, and the ITCZ is somehow trying to make its journey with the sun, is there energy being generated and sent northward that appear as intraseasonal oscillations. But this particular model, and the authors have done work which has claimed that actually a lot of the so-called northward propagating intraseasonal oscillations in the boreal summer are Rossby waves emanating from out here in the northwestern tropical Pacific, which is obviously a very active region in terms of rainfall, almost 5 meters of rainfall, so a tremendous amount of heating and energy is generated in that region. So you can imagine that that's a very important region. And you have these tilting structures that we have looked at before. But nonetheless, there are other people who have argued that the intraseasonal oscillations, or mesos, are independent of this structure here. And the other argument is that, like MJOs, the genesis of the convection happens here in the western tropical Indian Ocean, and the eastward propagating features are then somehow steered northward, and then you invoke the role of the easterly shear that gets set up during the monsoon as a background circulation, which you can also think of as thermal winds, because you have high amount of heating here in the Tibetan Plateau and the Arabian heat low, and you have the vertical shear that corresponds to, well, the thermal winds. But there is also a very strong meridional gradient of the zonal winds, so there is also a zonal shear, meridional shear, not just vertical easterly shear. All those questions remain somewhat unanswered, but this chapter uses the model that we already described, the 2.5 layer model, and develops a solution with it to argue that the model can explain the northward propagation and the various features. So you start with this figure of climatological July mean winds at 200 hectopascal, 1000 hectopascal, and this dark line here shows the region where the vertical shear is a -4 meter per second, so it's a strong region of strong vertical shear. So in the upper level you have the easterly jet, in the lower level you have the southwesterlies basically becoming westerly here over the Arabian Sea, Indian subcontinent onto the Bay of Bengal. But of course this has a very detailed behavior in terms of time scales, and it's zonal versus northeastward orientation depending on how strong the convection is. Over here, the Bay of Bengal can become very zonal, or when there is rainfall over the core monsoon zone, it can become very northeastward, and it has intra-seasonal variability, and it can go south of the Indian Peninsula to feed the Bay of Bengal, but also back circulation onto the core monsoon zone, and so on and so forth. And the specific humidities, of course, correspond to the loading of the moisture and precipitable water in the atmosphere during the pre-monsoon to monsoon season. So the southwesterly winds begin to get set up during the pre-monsoons, typically in May, and then the region gets very humid, but obviously the monsoon onset only happens at the end of May or early June, and sometimes delayed or sometimes a little early, and so on and so forth. So this is a sequential maps of figure of the sequential maps of lower tropospheric winds and precipitation rates in 2 millimeter per day contours for the Kelvin-Rossby wave packet induced by frictional convergence under nonlinear heating that we had already seen before, SST threshold, and the positive precipitation condensation heating. And in the July mean basic state. So this time, unlike the previous times, a background state has been prescribed, which is very critical for accomplishing this northward propagation during the boreal summer months. The straight line indicates tilted precipitation bands here, which is argued to be one reason why the mechanisms explained by this model are accurate, because it captures the structure which is observed. And the numbers denote the day of the model integration, which traces the location of the major precipitation centers. So you start with day 2, you have convection here, and you have rainfall here extending eastward, and then by day 6 you have this setup of the southeast northwest structure, which is like a highway for some of the Rossby waves, according to this author of this paper, Bin Wang, and his group has done a lot of work on that. Day 10, you can see that is intensified now, so clearly there is a lot of activity over here, and there is the monsoon activity over there. And there are many reasons for the damping and the humidity gradients over here, which are typically invoked during the MJO, in terms of why some MJOs get stuck on this side and do not transition across the maritime continent, why some of them get detoured southwards, and a few of them transition, but they get weaker over the maritime continent and then organize on this side into stronger propagating systems, and so on. So those include the topography over here. There are mountains that are almost 2 kilometers high, which can be physical barrier. There are some 22,000 islands here, which makes the ocean land contrast very strong, which can create the enthalpy exchange with the ocean to be very special in this region. Plus the diurnal cycle on land is very strong, which could be taking away the energy from the interseasonal time scales, and so on and so forth. None of those details are considered here, because this is an idealized model. So we are just looking to see if the processes that are represented in this model, especially the frictional convergence under nonlinear heating, can explain the northward propagation. So broadly speaking, the argument in this this section of the chapter by Bin Wang is that the model that's designed for MJOs and can explain so many things about the MJOs is also able to explain many features of the boreal summer ISO, or what we referred to before as the mesos. Of course, many things remain unanswered as well, and we will see in a bit also the more specific role of the easterly shear, which we showed here, and how that can create instabilities in terms of the horizontal vorticity it creates, the vertical motion, frictional convergence, coupling of the baroclinic vorticity and the barotropic divergence, and create northward propagation given the background winds and the northward humidity gradient. But there are issues with those arguments as well, and as I've mentioned before, you can clearly see the barotropic instability or the meridional gradient of the zonal winds as well. So there are some new ideas proposed now which argue that maybe the instability comes from the barotropic instability or the meridional shear of the zonal winds, giving the energy for northward propagation. So the main point I would make is that these things remain somewhat unresolved, even though the chapter focuses on this model and tries to say how many features are captured by the model, with the importance on the frictional convergence. And next, when we look at northward propagation, we will invoke the vertical shear, the easterly shear. So looking at the time, longitude, cross sections of the precipitation rate along 90 east, which is in the Bay of Bengal, where the northward propagation tends to be most prominent. And then you have the low pressure systems going off from the northern Bay of Bengal into the core monsoon zone, which are related to the active break periods. As we saw, the number of low pressure systems during the active periods are maybe 3 times or more higher than during the break periods. So we still have to understand the relation between the northward propagation and the low pressure systems. Of course, northward propagation and the convection creates conditions favorable for low pressure systems to form, and this is at 110 degree east, which is much more here. So here is 120 east, and 110 east is somewhere here in the South China Sea, Thailand, Burma region. So you clearly see northward or here, yeah, so this is time and this is latitude, so you see northward propagations in both these locations, 90 east and 110 east, in this model. So this is the argument that frictional convergence, the Rossby waves generated in the Western Pacific and their interactions with the frictional convergence can explain the northward propagation during the boreal summer, and can explain part of the monsoon interseasonal variability. We will look at a little bit more details about the northward propagation mechanisms in the next podcast. But once again, I would like to emphasize that this is one model which invokes certain processes rather emphatically, but that there is no consensus on exactly how that works, especially because we already talked about the propagation mechanisms for the 30 to 60 day time scale northward propagating systems and the 10 to 20 day systems, and we had invoked the Rossby waves, instability created by boundary layer processes and shifted northward by the mean flow, and so on and so forth. So all those details, whether there are 2 time scales and whether those processes are different, whether this model can capture both the time scales and both the processes and so on, is not something that we are going to get into here. But it's good to always remember that there are multiple theories, which means we still don't have a consensus and the story is incomplete. It's not a criticism, that's the way science works. It just means that you can still go and do a lot of research and produce new insights into this interseasonal timescale processes.